Hi, welcome back. Today we'll continue our series on mathematics of finance. We'll be looking at approximate yield to maturity, also refers to as the yield to maturity, the YTN. The yield to maturity basically represents the expected annual rate of return that is earned on a bond under the assumption that the debt security is held until maturity. What the yield to maturity is basically trying to estimate is just the total or the expected annual rate of return that is expected to be earned on a security in this case, which is the debt. So when you look at it also, there's this assumption that the bond needs to be held till maturity. Another assumption is that all coupon payments are made on time. Then the last one, which is the reinvestment risk, which is that the coupon received are meant to be reinvested at the same interest rate. Remember, recall, like I said, reinvestment rate. So what reinvestment is trying to say basically is that when coupon payments are being received, because you are trying to hold the security until maturity, you need to actually reinvest back those interest payments that has been received. So the risk now come into place that can we find a similar asset, a similar security at that same particular rate as the initial security? That's when the reinvestment risk come into place. And how do we measure our yield to maturity? We have two formulas on the screen. They are basically the same, just the notations are basically different. So the first one we have PT and we have PO, then we have C. So C basically is our annual interest payment, which is this. Then the second one, which are PT. Our PT is our par value, or what is referred to as the face value. Then we have our PO. Our PO is the price of the bond. We have our N, which is our years to maturity. Our years to maturity. So we have the second formula basically saying the same thing, just the way they are denoted are different. So we have FV, which is our face value, and we have PV, which is our present value. Same thing referring to as the price of the bond. So we have those two formulas in which we can use to calculate YTM. So we'll take a quick example so we can actually see how this works out. So we have a question here saying, suppose an investor purchases a $1,000 face value bond. We have face value bond here, which is basically selling at 878.50 dollars, which has 4 years to maturity, 4 years to maturity, and has a coupon rate of 10% per annum. So the first thing we need to derive from the question or from the formula given, the first thing that we need to get is basically our C. So our C is our annual interest payment. So how do we get that? So come here. Our annual interest payment is going to be our coupon rate. C is going to be our coupon rate, which is going to be multiplied by the par value, the face value of the bond. So from the question, we can deduce that our coupon payment is 10%, which is 0.1, multiplied by our face value, which is 1,000, Given that we have 10% of 1,000, that is 100 naira, $100 rather. So we've gotten our first variable. The second variable that we need is basically our PT, our P subscript C, which is our face value. So our face value from the question is $1,000. Then the second variables we need is P naught, which is basically price of the bond, the fair price of the bond, which is $878.50. And our last variable, which is our number of years, which we can see from here, 4 years to maturity. So we have our variables intact. All we need to just do is basically impute this into our calculator, and we are going to have our answer. So I'm going to click on this. So our C, which is our coupon from the question, yeah, we have 100 plus, then we have another this. Then from the formula we have PT, which is 1,000 minus the price of the bond, which is this, divided by number of years. We have 4 to be the number of years. Then we have the denominator. We have the denominator basically. So click on that also. So our PT, which is basically 1,000 plus 878.50 cents divided by 2, as we have from the question. So we have equals to. So approximately our answer is 13 point. If you convert that to percentage, basically that's 13.88. So we have 13.88%. We have 13.88%. So our yield to maturity from the given question amounted to 13.88%. Thank you so much. We'll meet in the next video.